Hi, Algebra 1 guys. Here we are, video number 2. Hope you got to do those graphs on exponential decay, and you should have noticed that they all looked very similar. They were just, some were steeper than others, but they were pretty much the same. So today we want to talk about real life exponential growth. And one of the things we talked when we were still together about some things that are growing exponentially, and certainly of all things, how timely, the coronavirus was one. You know that money can grow exponentially. We talked about how tuition at St. Ignatius High School, unfortunately, is growing exponentially. So I thought it would be fun if we did some actual real life problems today. So let's suppose you had, how much money? $2,000 saved up. You saved everything since your first communion and every birthday and your 8th grade graduation and confirmation. So you have $2,000 saved up, and instead of keeping it under your mattress, you're going to put it in a savings account that you're lucky enough to find one that is going to give you 3% interest. And I would like to know how much you're going to have in 4 years when you go away to college. So this is the way, if you only got interest once a year, here's what you'd have to do. You would have to take 2,000 times your 3% interest. And remember, the quick way to find 3%, we're going to knock 2 zeros off and multiply by 3. So if I knock 2 zeros off and multiply by 3, that's going to give me $60. So at the end of year 1, you are now going to have $2,060. Does that make sense? Okay. So then the second year, you now have $2,060 that you're going to get 3% on. So now, when I multiply by 3%, let's see if Mrs. A can do that in her head. We're going to basically kind of knock this 0 and put the decimal here. So what's that going to be? I think that's going to be $61.80 if I'm doing my math right. So now you're going to have this amount added on here. So if I add $61.80 onto that, you are now going to have $2,121.80 after your second year. Then we would do that a third time and a fourth time and find out how much money you would have at the end of 4 years. But that just seems like a lot of work, doesn't it? And I know you guys aren't going to want to do that. So fortunately for us, there is a formula that is going to allow us to do this by using the formula and not have to go through the process 4 times. Or if it's longer years, it would be more. So here is what we call our exponential growth formula. Okay? Remember this, you should all be taking notes. Okay, now this looks complicated, but it's really not. So what's Y, what's A, what's R, what's T? Here we go. Y is going to be the future value of your money, including what you started with plus all the interest you're going to get. So basically, the amount you'll have in 4 years. A is the initial amount. How much do you start with? So in our case, it was $2,000, remember? R is called the growth rate. And we always put that in as a decimal. And T is the time. Okay? So if I want to use this formula to find out a little bit quicker way how much I'm going to have in 4 years, That's what I want to find is y. So I'm going to put y there. My initial amount A is $2,000. I'm going to put 1 plus, my interest rate was 3%, and we want to see how much you're going to have in 4 years, so I'm going to raise it to the 4th power. So you can see why this is an exponential growth, because remember, if I add 1 plus 0.3, I have 1.03. That's a number, the base is a number bigger than 1, so it's going to be a growth function. So let me show you how to do this on your calculator. So I'm going to get rid of that, and I'm going to pull up my calculator. And I'm going to do exactly what, I'm just going to type everything in exactly as the formula says. So I want to multiply 2,000 times, I'm going to put parentheses in just like we did, and I'll even put in 1 plus 0.03, although we know that is just 1.03. If you want to just put 1.03 there, you can. Now, do you remember how to raise something to a power? You've got to use the up arrow, and I want to raise that to the 4th power. I'm going to hit enter, and you are going to have, not sure if you can see this, but if you're doing this on your calculator, I'm going to round it off to the nearest cent, and you will have approximately $2,251.02 in 4 years. Okay, so that's that one. Okay, now let's go back. Let's go back to let's do another one. This will be a fun one. Of course, not so fun for you guys, but it'll make your parents feel better. Right now, tuition is $17,800. Or is it, no, it's $17,300. There was a 4% increase this year. And I would say over the last 10 to 15 years or more, it's been even 5% at times. So let's say it's going to grow at a rate of 4%. I'd like to find out what tuition's going to be when you guys have a son that comes to Ignatius. So let's just think about this. You're 14 now, I'm assuming. I know some of you are 15, but we'll do 14. And let's suppose you are going to get married, have your first child when you're 30 years old. Okay? So your son is born when you're 30. And then he's got to be, so that's 16 years. And then he's going to be 14 when he's a freshman. So altogether, that would be 30 years from now. Do you follow? 16 years till you have your first child, and then another 14 before he's a freshman at Ignatius. So we want to see what tuition would be in 30 years, which would be about when your son would be a freshman. So do you have your calculators? You can pause this. That's a good thing about videos. I'm not going to pause, but you can pause and go get your calculator, and we can do this. So I'm going to clear this out, and what do I have to multiply? 17,300, which is what the tuition is now, times parentheses 1 plus, our growth rate is 4%, we're saying this time, and I want to raise that to t, is that because it's 4% per year, my t has to be in years, and that's going to be, I'm going to raise it to the 30th power. Now, I'm almost afraid to push this button. It's going to be sticker shock for you guys. Enter, yowza. If we round this off, tuition is going to be approximately, I'll even round it off to the nearest dollar, $56,110. Now, I know that sounds ridiculous to you, but remember that salaries are going to grow in 30 years, and everything else is going to grow too. but it is a lot of money, something to think about. So, now, that's that. We can get rid of that now. Get rid of that. Okay, so that's how we use our exponential growth formula. Well, let me do one more. Okay, let's suppose that you have $5,000. No, let's not do that. Let's suppose that you want to have enough money, you want to have $20,000 to buy a decent used car when you graduate from college, which should be in 8 years, correct? Does that make sense? Okay, and so you want to have $20,000. So I am not going to put that in here as the initial amount. That's the future amount that I want to get. So I want to get $20,000. And you're lucky enough to find a bank that'll give you 5%. And we would like to know how much money you'd have to put in now, put away now at 5%, so that in 8 years you'll have $20,000. So now my $20,000 is going to go here because that's the future value I want to get. I don't know, I'll use A because that's in the formula. I don't know what I have to put away now. I know I'm getting 5%, which is wonderful these days, and I want that to happen in 8 years. Now, the question is, how do I solve this problem? Come on, it's Algebra 1, you know that. So let's do this. This is just 1.05 to the 8th power. So why don't I go to my calculator? Well, let me ask you this. Whatever this number is, to solve for A, aren't I going to divide both sides by 1.05 to the 8th power? I mean, think about it. If you had 12 equals 3A, how do you solve for A? You divide by 3. So I'm dividing both sides. So this is just going to be 1. So my answer is going to be whatever 20,000 divided by 1.05 to the 8th is. So I'm going to go back to my calculator, get that horrific number off of there, clear that, and I need to take 20,000, one more, and divide by, now, your calculator will know 1.05 up arrow to the 8th power. Now, remember your calculator is scientific, so it's going to use the correct order of operations. So it will actually raise the 1.05 to the 8th power first, because remember PEMDAS, exponents before dividing, and then it'll divide. But if you wanted to be on the safe side, you could put that whole thing, 1.05 up arrow to the 8th in parentheses, just, oh, wait a minute. Oh boy, okay, back, 1.05 up arrow to the 8th, okay? So let's hit our enter on here, and I'm getting an answer of $13,536, and I'll round this one off to the nearest cent, 79 cents. So that means you'd have to have $13,536.79 right now to put away into that bank. That's going to give you 5% interest to have $20,000 when you graduate from college. Okay, so that's another kind of problem. All right, and one other thing, and then I will wrap this up for you guys. So now, we said not everything grows, some things decay. So exponential decay formula is just going to be a little bit different. It's going to have a times 1 minus r to the t power. So there's going to be a minus sign in there instead of. So something that would decay would be the value of a car. Radioactivity, radioactive materials decay over time. A lot of things that decrease as time goes on. Temperature of something that's cooling off decays. So that's the same kind of formula, but it's 1 minus r. Now, you're going to have to do one worksheet. So this is decay, and remember the growth was y equals a times 1 plus r to the t. Now, some important vocabulary for you. This r is called the growth rate. You're going to be asked to give the growth rate in some problems. What is the growth rate? It's simply the rate, the percent that you're being given or that you're losing, that you're gaining or losing. Okay, the whole 1 plus r or 1 minus r is what is called the growth or decay factor. So there's a difference between the growth rate, that's just your percent. The growth factor is the whole 1 minus r or 1 plus r. Now remember, if it's 1 plus r, that's going to give you something greater than 1 and it's going to grow. Remember how we talked about if you multiply something by bigger than 1, you're going to get bigger? If you start with 1 and subtract something, you're going to get something less than 1, and that's going to cause, when you multiply something less than 1, you get less and less and less. Okay, so there's a worksheet online somewhere that you're going to have to do with some practical real-life application problems. So that's your next assignment, and I'll see you with the next topic. Bye, guys.